Okay, so we just talked about a whole bunch of different types of angles in these different theorems. What I want to do is I want to show you just kind of where those angles are, because you do need to know that. Okay, the first type of angle that we talked about was corresponding angles. And you should have that in your foldable, so please make sure you do. If you missed it in the video, ask your kind substitute to please go back and show that slide, or look in your textbook, because it is in section 3.3. Okay, so our first type of angle was corresponding angles. Those are right here. If it's, again, corresponding angles have to be on the same side of the transversal, and they have to look like they're the same. So if I pick this one, and we'll put the word corresponding in there. Okay, for this angle here, where does this angle correspond to? It has to be on the same side of the transversal, and it has to look the same. The only angle that looks the same is this guy right here. So these two are corresponding angles. They're on the same side of the transversal. Another set could be here and here. Okay? We also talked about alternate interior angles. Alternate interior angles sound like they're inside. Alternate interior is inside these parallel lines. So for us, that's going to be on each side of our transversal. Okay, so here is a set of alternate interior. Here is the other corresponding one to that alternate interior. Okay, we could also say this one and this one are alternate interior. Another one we talked about is alternate exterior. Alternate exterior is on the outside of those parallel lines, okay, and they have to alternate on that transversal. So here's one. We'll say, I don't know what I just wrote there. Exterior, okay, it's other exterior angles on the other side of that transversal, and it's got to be, looks like it's about the same. So here's the other one. Okay, we could also say here and here. So they have to be on the outside of those parallel lines on alternating sides there. Then we talked about the consecutive angles right here. If they're consecutive, they're on the same side of that transversal and they're right next to each other. So this one and this one, those guys are consecutive, and when you add them together you should get 180 degrees. Okay, so those theorems and postulates should be in your foldable. This kind of summarizes what they are, and we're going to continue with some proofs and examples. Okay, so now we are actually going to get into an example. We want to prove that if two lines are cut by a transversal, the alternate interior angles are congruent, the lines are parallel. So what we first want to do is, you'll notice we are given a diagram here, but we're not given any prove or given statement. So let's think about what they're given. What that diagram shows me, I look at angles 4 and 5, and I see that they have that similar or the same arc, telling me that they're congruent. So that's going to be our given. We're going to say given angle 4 is congruent to angle 5. Let's think, what are we trying to prove here? Okay, it says prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, and we just said that's a given because they're telling us that in a diagram. Prove the lines are parallel. So we are trying to prove that line G is parallel to line H. And don't forget, guys, the symbol for parallel is two double lines next to each other like that. Okay, so now we are going to go ahead and write our statement versus reason chart. Okay, and we know this by now. First step is always go ahead and write that given down. So we're going to write angle 4 is congruent to angle 5. And that reason is that it's a given. Okay? Step 2, let's kind of look at our given. And we'll say, okay, we are given angle 4 and angle 5 are congruent. I can't really do anything with that. I can talk about how their measures are equal, but that's not going to help me a whole lot. So what I might say is, okay, I have a 1 there. Maybe I can say something relating it to angle 1, and then I kind of look at this diagram here. Maybe I can say something about how those are corresponding angles. Okay, so the way that I can kind of bridge the gap between this statement and angle 1 is I can notice, angle 4 and angle 1 look like vertical angles to me. And what do I know about vertical angles? They're congruent. All right, let's go there. Angle 4 is congruent to angle 1. And that's by the vertical angle congruence theorem. Okay, and that's a theorem that we did write down previously. That says that if two angles are across from each other like that, that means that they're congruent. I'm not really wanting to go into the definition at all. I just want to say that it is a vertical angle, so it's congruent. So that's why I wouldn't use that definition. Okay, now I've made 2 statements. Let's see if we can bridge the gap a little bit and make a property statement. I'm going to look at my 2 angles and I'm going to say, what is the same? What property can I use? And I notice angle 4 is repeated in both of them, and that's money. I like that because now I can say, well, these are the same. I'm going to use my transitive property to say angle 5 and angle 1 are congruent. And that's by my transitive property. Okay, I'm almost done. Right now, I'm at the point where I have angle 5 and angle 1. Let's kind of think back a little bit. We just wrote a whole bunch of theorems and properties down, so you guys might want to take a second and look through those to see what we can say next. But you do have a theorem that says when you have corresponding angles congruent to one another, that proves your lines are parallel. So we can go right ahead to angle 4, and we can say that because angle 5 is congruent to angle 1, that means line G is parallel to line H. And the theorem that we're going to say for that is the corresponding angles